Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm Zach Memes, your host for this episode of CompTIA Linux Plus. Troubleshooting Services, the title of this episode. And once again, our expert Don Pizzetta is here to help us out. Don, good to see you. Thank you for joining us.
Glad to be here, and we're going to have fun in this episode because we're going to talk about things that should work but don't always work, which is kind of par for the course with the computers. We know from earlier episodes that we can set up services to run, and they usually run great. But when things go wrong, what do? Well, in this episode, we're going to take a look at some of the tools that are available in most Linux distros to be able to either diagnose and identify processes that are causing problems, or try and end them, try and get your system going. Basically, what we're going to try and do in this episode is avoid having to reboot our system to fix our problem. And you'll see there's a lot of different things we can do to fix that. So that's what we're going to be taking a look at right here in this episode.
What are some of the common problems we can have with processes under Linux?
Well, the main problem is when a process hangs, right? Where something just goes wrong inside of the process and it effectively freezes. It just gets stuck. And there's a number of things that can cause that. Like, there's physical things. Like if you have a bad RAM stick in your computer, a lot of times you won't notice that your memory is going bad. It's not until that little address in memory actually gets used that you run into the problem. And if an application puts some data in memory and then goes to retrieve it and the data is different, the application freaks out and it hangs. Now, when it hangs, it's usually holding resources open, like holding some memory or CPU cycles or whatever. And now those resources aren't available to other programs. So you've got one program that's damaged, stuck, and it's now affecting other programs because it's hung up. And that happens, it happens in a number of scenarios. Usually it's tied to either a hardware failure or some kind of programming or development issue. Those can all kind of lead to that. We also have processes terminating, right? You've probably encountered this at some point where you're running a program and all of a sudden it just goes away, just disappears, right? And what happens is it had a critical fault that was so critical it couldn't even continue operation, and it just winks out of existence, right? And those are usually a little easier to fix because at least it didn't bog your system down, right? We go in and we can identify it. The other thing is we can have resource starvation, where one process is running, and it's running, it's doing its job, but it's consuming all the CPU or all of the disk I/O, all the network bandwidth or something of that nature, and making it where nothing else can run on your system. And they can even get so bad that you can't even administer the system. Even your shell is too burdened. There's not enough CPU cycles for that, and you end up having to reboot the computer to free things up. Those are some common scenarios, and I know this is the Linux Plus show, but everything I just said really could apply to Windows and Mac OS too. These are common problems that we have with processes.
Well, how does a normal process behave then, Don?
All right, so
how is it supposed to behave?
what we hope to have happen.
Yeah.
Under Linux, applications run through five states, right? It's called the process lifecycle, and you execute an application one way or another, right? Maybe you're double clicking on an icon, maybe you're running a script from a command line, or maybe you're just booting the computer up, right? Because all the services and daemons, they start in the background, so those are all processes that are starting, right? And when they run, they have a job to do. And as long as they're doing that job, we're happy. If it's an interactive application, we see it on the screen. If it's one the system's powering, it's all being done in the background. But that first state, that's just called the running state. The application is running and doing its job. Okay. Now, ideally, the job finishes and it jumps to the final state, which is stopped. The application is stopped. It's no longer doing its job and it closes out, right? But there's a couple of states in between that it might pass through on its way in, right? If an application is running and it's waiting on something, right? Maybe it wants to save to a file, but the file is currently in use. Or maybe it needs to access the network, but the network's too busy, or somebody else is already there first and it's got to wait a moment. Then what it's going to do is the process is going to go to sleep. And when it's sleeping, there's two different kinds of sleep. There's interruptible sleep and uninterruptible sleep, right? Uninterruptible sleep says it's going to wait a period of time and nobody can wake it up until that period of time is up, and then it's going to wake up and check again, right? Interruptible says it's going to go to sleep, but anything can kind of cause it to wake up. Like if the resource becomes available, it can queue it. Actually, with uninterruptible sleep, it'll wait and it'll wake up and only wake up if that resource is available. Otherwise, it stays asleep. But interruptible can wake up for any number of other reasons too. So different reasons. A process that's sleeping is not necessarily a bad thing, right? Although it might indicate a problem with some other process if we're deadlocked. Deadlock is when two applications are waiting on each other, right? Let's say Zach opens file A and I open file B, okay? And then I want to access file A, which Zach has, and Zach wants to access file B, which I have. Well, I'm waiting on him to close his file. He's waiting on me to close my file. What's going to happen? We're deadlocked. We could both wait forever, and it'll never
Sounds
open.
like a collision.
Yeah, so that's a problem that we can bump into, and it won't be resolved until I get one of us to close our file so the other can do their job. That happens with processes, and the operating system will try and detect that, but it doesn't always work. Now, when an application is done doing what it's supposed to do, if it's a process, oftentimes we'll see that a process will launch more than one process to do its job. So you have the parent process and child processes. If you're a child process and you finish and you're done, you're actually not allowed to go to stopping until the parent process says it's okay, because the parent process might just give you another job to do. And so in that scenario where the child process is waiting, it can go into what's called a zombie state. And zombie, that sounds like a bad state as well, right? But it's actually okay. It's decent. It's okay for it to be there. It just means the parent hasn't cleared that process to close yet. It could indicate there's a problem with the parent. If the parent has hung, right, then there may be an issue there. But otherwise, it's fine. The parent releases it, and then it goes to stopped. So that five kind of state, that five life cycles, 5 stages of the life cycle or whatever, is we go from running and then potentially to an interruptible sleep or an uninterruptible sleep, potentially to a zombie state, right? All three of those are optional. And then lastly, to a stopped state. That's what we expect to see with our applications, all normal behavior.
What is the best way to view processes as they're running?
All right. Well, I mentioned a few times this stuff is usually happening in the background and we don't see it. Or if I launch Firefox, I just see Firefox running and that's it right here. If I go, I've got my CentOS machine. If I fire up Firefox with an interactive application, I'm going to see this right here on my screen, right? So I'm running it. It's here. It's not happy, but it is running. There we go. So it's up, and I know that it's interactive. If this were running in the background, hey, even if I minimize it, right? I don't necessarily know that's going on. In the terminal, we can actually view all that stuff that's happening in the background, and this would include things like services. So if I have a service, let me just start up HTTPD. All right. So I'm running Apache in the background. I'm running a web server, but I don't see that. Now, I started it, so I know it's running. But if somebody else came to this system, they wouldn't know it's running. It's in the background. And so we have a few different tools that let us see what's going on. And one of the best commands is one I mentioned in an earlier episode. It's PS, right? And what the PS command does is it shows us our process table. Now, the PS command is super useful, and it's one of the oldest tools in the Unix toolbox. In fact, it's so old that it's been updated a number of times, and it's kind of made it a little more complex because there's the original Unix version of PS, then there's the BSD style version, and now there's the GNU version as well. And so what most Linux distros have done is said, you know what, we're just going to honor the command line arguments for all three. So when you pull up the man page for PS, you'll see different options here, all listed by these 3 different types of operators. So different people learn to use PS different ways. Like when I got started, I started in Solaris. That was my first Unix operating system that I worked, which is all BSD. So I learned the BSD operators. But the original Unix ones are actually some of the easier ones, and the GNU ones are the longest ones. But it doesn't really matter because they all work at the end of the day, right? So it's just kind of warning us here in the documentation that whether you use a hyphen or not is going to make a difference. If there is a hyphen, then that's going to be your Unix style option. If there's no hyphen, it's a BSD style option. And if there's 2 hyphens, that's the GNU style option, right? But let me just kind of show you the most common uses of these. I typically do PS AUX, which actually was the example right there in the man page. This is probably the most common usage. And what we're doing is we're telling it, I want to see some processes. The A tells it I want to see all processes that were triggered by a user. So anything that a user ran, right? So if I ran Firefox, that is going to be shown. And then U tells it to show me the user name, right? If I know the process was triggered by a user, well, I want to see the username that's attached to it, so I know who did it, right? And then X is kind of an interesting one because there's some applications that run without a terminal. And an example of that would be my web server in the background here. That web server is running in the background. It doesn't have a shell open, right? It's just Apache running. And so even though I'm saying A for all, it's really saying all things triggered by a user, which would always be triggered from a shell. So adding that X gets me to see the services as well. And when I run that, I'll get a nice big screen layout right here. Now, on CentOS, any user is really allowed to fire this up and you can see information. On some systems, they do permission restrict it. So you might need to add the sudo command to the beginning in order to get the full output and see all the processes from other users. But once I do that, I can see the processes that are running and see the username on the left side. I've got root or dpossess. So I know who ran something. And I ran Firefox earlier and I actually kind of lucked out because I can see it right here on the screen. Remember I mentioned parent process and child process? I actually see more than one copy of Firefox running. I don't actually have more than one copy. I just have this one, right? Well, as you start spawning tabs and browsing to websites and doing things, each of these, we'll pull up CNN and Fox News. That way we can kind of balance out everything.
Yeah, that'd be balanced.
So as you do these, it will constantly spawn new threads to be able to go out and new processes to be able to reach out and render this stuff. And over time, you may see something pop up more than once in there, especially if you're on Google Chrome. Oh my goodness, it's just process crazy. You'll see them all on the list. But I can see that they're running and I can see a little bit about them, right? All these columns are tied to information about those processes. So let me do this. I'm going to pipe that into the head command. So I just get the first 10. And that way I can see my headers nice and quick. What we're looking at here is we've got the username, and then you've got the process ID. Every process that runs has an ID number attached to it. And that ID number is pretty important so that we can tell one process from another. If I have 2 Firefox processes running and I want to troubleshoot one of them, I have to have some way to tell them apart. And the process ID lets me do that. I can see how much CPU they're consuming and how much memory they're consuming. And we can see when they started, how long they've been running. And then the command that was actually executed to make them start. So, a lot of really good information to be found here. And what you'll find is there's a lot of processes that have been running in the background. When I ran my full PS aux command, I can see the current process ID number here is 13,464. All right. Now, I powered this computer on not too long ago. I have an uptime of 25 minutes. Ooh. And so in 25 minutes, this system, which is under next to no utilization, has spawned over 13,000 processes. It's not uncommon to see this number sky high, right? If your server's been running for months or years, the numbers will be really, really high. It's just keeping track of that and identifying those processes.
Don, how would we know if a process is misbehaving?
Looking at it in PS, we kind of have a hard time identifying if something's misidentifying because we get stuff in here like the CPU utilization and memory consumption, but we're seeing it right then when we ran the PS command. And so that might not be a good window. Like sometimes when you meet somebody and you shake their hand that first time, you get an impression, right? Well, if you caught them on a bad day, that might not be a very good impression. But if you get to know them, all of a sudden you learn they're a great person. Or it could be the opposite, right? You think they're great.
Oh, I've experienced that.
So processes are the same way. It's like personal relationships, right? So I just shook the hand of these processes. And at the time, they all looked like they were doing great. But they could be misbehaving right now, and I wouldn't know it. So we need a tool that's a little bit more real time. And a great utility for that is the top utility. If you run top, just TOP, when you run that, it will show you the top resource consumers inside of your system. The output is very similar to what we saw with PS. The difference here is it's sorting them by utilization. And if you watch my screen, it's actually updating, right? Things are changing and different commands might bump up to the top. I see Firefox right here in these web content processes. That's a part of Firefox. So Firefox right now is the #1 consumer. But maybe I go and start generating some other activity on my system, and that could become the top consumer. Like if I do an encrypted file transfer, that's going to jump up because it eats up CPU so much. So Top does a good job with that. Now, by default, when I look at it, it's sorting by CPU consumption. So when I look at let me zoom in just a little bit here. I can see my GNOME shell just bumped up to 16% while I was doing that zoom operation, right? But then after that, it dropped back down, and Firefox is now taking back over. And I can see that it's at roughly 15% of my CPU. Now, is that a problem? I don't know. Maybe, right? It isn't, right? 15% for a web browser is actually pretty good. So it's running like I should expect it to. But if I see it at 99%, right, then that's going to indicate it's consuming a lot of resources. Now, if I'm encoding video, that's going to use as much CPU as it can get. That's normal, right? But if I'm just sitting here idle, I don't expect to see 99%. That can indicate a process is acting up. Also be aware if you have a multi-core system, the number might go over 100% because you've got numerous cores that get involved, so that can happen. Now, the other thing is this is sorted by CPU. What about memory? What if I have an application with a memory leak and it's consuming more and more memory over time? All right. Well, we can change the top command to tell it to sort by something other than CPU. There's some keyboard shortcuts you can use when you're looking at it. If we do a capital M tells it to sort by memory, right? So now it's sorted by memory, and I can see, well, Firefox is consuming the most memory on my system. But if we were running MySQL or something like that, it would consume a bunch of memory, and we'd be able to spot that here. And if you see it steadily increasing more and more and more, that could indicate a memory link. And with Firefox, the more web pages I open, the more memory it'll consume. So if we just kind of keep pulling up web pages here. Oh, I'll do Facebook. Facebook loads so many trackers, it consumes quite a bit of memory. Although CNN's pretty bad about that too. We'll go to Twitter. All right, so I'm just opening more and more web pages. And if I go back and I can look, that memory, I went from 10.7%. Now I'm at 16.5, right? So it's consuming a little more memory. And now that I'm idling, it's going to start, hopefully, swapping some of that stuff to disk if it needs to. If I have plenty of memory, it may keep it all on RAM. And actually, I see my memory is still creeping up. It's still loading ads, I'm sure. So we can kind of monitor. Oh, see, my CPU just went to 101%. That doesn't normally seem possible, right? How do you get to 101%?
The shampoo ads.
I've got 2 cores, right? So, the shampoo ads will actually do it.
They'll do it.
Those autoplay videos and stuff, they'll spike your CPU.
That's the one.
So in my scenario, I might have 2 cores running at 50%, which is fine, or 1 core is maxed out, and now it's starting to use a little bit of the next core over. So that certainly is a potential there. So we can see a lot of that. If I want to switch back to CPU, I can do a capital P. So capital M took me to memory, capital P takes me to CPU. There's plenty of other ones, like if I just want to see the processes that I ran, right? Let's get rid of all these other ones. I can hit the letter U, just a lowercase u this time, and you can type in a username. I'll type in dpossett, and now I'm just seeing my processes, which is pretty handy. Kind of filters out a lot of the system stuff that gets in the way. You can do, well, let's say that I know Firefox is my problem, right? And it's really causing an issue. I can find Firefox in the list and pay attention to what its process ID is. So Firefox right here, I can see has a process ID of, whoop, it jumped on me, 12,795, I think is what it said. Yeah, 12,795.
Okay.
You can hit K on the keyboard, and K is short for kill. And you can type in 12,795, typing in the process ID for Firefox. And when I press enter, it's going to send it a sig term. It's a signal to terminate. And so it's going to tell that program that it needs to shut down. And when I run it, notice in the background, Firefox just went away. And Firefox has some child processes, right? Those web content processes, those just went away too, right? Because when Firefox terminated, the other ones, they basically went into that zombie state, saw Firefox was gone, and then stopped and went out. So that's all stuff we can do from top, and it makes it really, really easy to identify anybody who's like a resource hog, is consuming more than they should.
So, Don, what if we can't get to the top command, like when our system's booting up?
Yeah, really good point, right? So I'm logged in here, right? I can get at this stuff. I can launch top and so on. But if your computer's taking like a long time to boot up, there's likely a process that's just taking a long time. It'd be nice to identify when that is. Top is showing me real time right now. It's not showing me the past. I don't see what was going on when the system was booting up. So I'm going to hit Q to quit out of top. And I want to show you a neat command here. If you're running systemd, which the majority of Linux distros are running systemd these days, there's a cool command called systemd-analyze. And what it can do is it can troubleshoot systemd on your system. And it's got a cool command line argument that you can use called blame. And basically what it says is when you boot it up, who's to blame for how long it took this system to boot up? And it helps you to identify what's dragging it down. Because I'm sure you've all seen at some point, you fire up your laptop and it takes 1.5 minutes to boot. And then your buddy comes along, they fire up their laptop, and it's like 10 seconds. It could even be the same hardware. It happens, right? It all depends on the software that we've installed. When I run systemd-analyze blame, it's going to give me a list of all of the services that started when I booted my machine up, and it's going to tell me how long they took. So I can see like systemd-udev, that's where it detects all the hardware devices and assigns a name. It took 3.8 seconds, right? And then after that, my network manager, it took 2.5 seconds, most likely because it was waiting on DHCP responses. Then we've got LVM, my logical volume manager, took 2.5 seconds. Well, if I see somebody in here that's like 60 seconds or over a minute or whatever, that's a problem. If I can see MySQL or whatever, I need to look at that. And maybe it's a really complex process and it just takes a long time to start. That's possible, right? If we expect it. But if I'm seeing an unexpected long boot time, the system deanalyze blame command. I mean, it'll dial it right in. You'll find it real quick and see what that problem is. It's also a great way to compare your boot time to other people and say, well, UDEV for me is taking almost 4 seconds. How long does it take for you, Zach? And then you can run the command and you get the same output. So it's another cool way to see that. One more thing I want to mention is sometimes an application is frozen waiting on another application. I mentioned that earlier in the episode. It's useful sometimes to be able to see what file it is they're waiting on. So if I have an application that's kind of stuck and I think it's waiting on a file, or if it tells me it's waiting on a file, I might kind of scratch my head, right? Well, what process is holding open that file? I don't know, right? Well, there's a really cool command called LSOF, right? Or list open files. And it will show you the files that are open by various processes. Now, if you just run it by itself like that, you get a ton of data. So what I normally do is try and be a little more targeted, right? So let me do this. I'm going to open up another tab, and I'm going to create a file, test.txt, okay? And, this is a file. It's very exciting. And I'm going to save it. Okay, so I've saved the file. Now, actually, here, I'll quit out, and I'll re-edit it. There. So Vim is holding this file open, all right? It's working with this file. If I have another application that's trying to write to test.txt, that's going to cause a problem, right? So if I don't know that Vim has it open, or I don't know that another user has it open, how do I figure that out? And what you can do is you can run LSOF, so list the open files, and you can pipe that, use the pipe character, the 2 vertical lines above your enter key. You can pipe that into the grep command, and you can grep for your file name. Now, I want to grep for test.txt. That dot is going to be a bit of a problem. Remember, grep uses regular expressions, and a dot is technically a wildcard. So I need to stick it in quotes and say test \txt and end quote. And that way, it knows that I actually want to look for a real period, not a wildcard. And when I run that, it's going to show me the application that has that open. And I can see right here, user dpossett is editing that file. And actually, it's showing me the swap file because Vim works with temporary files. Mm-hmm. But I can identify that, and I get the process number right there. So if I'm an administrator and I say, oh, man, Don's gone home for the day, and he's got this file locked open, well, I hope he saved his work because I'm going to kick him out. And then we could go into Top or some other program, and we could go and kill off that test, or kill off Vim in this case, which would then release that file and let them let the other program get back into the file.
So, Don, I know that we have touched on other ways to end services, and I'd love to hear about them, but, we're running a little bit short on time. So, Troubleshooting Services Part 2 will be coming your way, and hopefully you'll join us for that. I'm sure you will. I know I am. And before we move on, though, Don, anything else you'd like to say?
A lot of what we've seen in this episode has just been identifying the processes that are problems. So definitely stay tuned for part 2 because that's where we're really going to kind of fix things and kill them off. It's fun. Stay tuned.
Thank you, Don. Can't wait. CompTIA Linux Plus, wonderful series. Don's done a great job putting this together for you. Lots of information you can use now and in the future. It will help you with those exams that are inevitable. And don't forget about extra study. Very important. Inside of our course library, there's all kinds of supplementary information that is there to do one thing, help you be even more successful. So check that out, too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Possett.
We will see you again soon.
Thank you for watching IT Pro TV.